Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 2, Lesson 3 on Linear Equation Solving Review. Now, I know it's probably going to sound surprising to some of you sitting in Algebra 1, but in theory, through 6th, 7th, and 8th grade math classes, you are actually supposed to learn just about everything in terms of solving what are known as linear equations. Linear equations are simply equations where the variable, x, n, t, r, whatever we want to call it, is at most to the first power. So there's no negative exponents, there's no, x to the second or to the third or the square root of x or anything like that. Trust me, we're getting into a lot of that this year. All right, so what we want to do in this lesson is we really want to just go through a variety of different linear equations, right? Even though the last lesson we looked at using inverses to solve equations, and we'll do a little bit of that as well today, and I'll kind of emphasize that here and there. But ultimately, we just want to get a really good practice set of problems that kind of stresses solving linear equations. So let's get into them right now. All right, basic equation solving review. That's pretty much everything I just said, but it's expected that you enter Algebra 1 already having fluency in solving all types of linear equations. No exponents other than 1. So let's bring exercise number 1 up here, and let's take a look. Exercise number 1. Solve each of the following two-step linear equations. Keep in mind, this is what we were doing in the last lesson by reversing the operations that had occurred to the variable. Some of these answers will be non-integer rational numbers. Simplify where possible. All right, so it's funny. In 6th grade, you were supposed to learn how to solve one-step linear equations. In other words, equations that you literally had to do one thing to get x all by itself. Then in 7th grade, you started solving equations that were two-step equations, and that's what we're going to be working on here. In 8th grade, you basically then piled on with that by having variables on both sides of the equations in order to get a two-step equation, etc., etc. Finally, one last thing I want to mention before we move on, right? Some of your answers will be non-integer rational numbers. What you should read that as is you're going to get some fractions, okay? You could also turn those fractional answers into decimal answers. That's fine. You should have your calculators handy. I'm not going to be using one today because I don't particularly feel like it's absolutely necessary. But if you feel like it is, then have it there. I want you getting the right answer, even if you have to use that calculator to help you with some of the arithmetic. So let's jump into it right away, and let's do letter A, maybe have you do letter B. I think we want to take a look at letter C together, but we'll get there. So let's take a look. Letter A. I've got x divided by 3 minus 7 equals negative 2. All right, so let's talk about this a little bit, right? We can think about sort of order of operations, what's been done to x, reverse it, etc. Ultimately, I have x divided by 3 minus 7 equals negative 2. So I'm going to then add 7 to undo that. I'm going to multiply by 3 to undo that, and I'm going to have my answer. Two steps, right? Here we go. I'm going to rewrite my equation down. X divided by 3 minus 7 equals negative 2. I'm not sure why I felt the need to write it down again, but I did. So then I'm going to add 7 to both sides. I'm going to have x divided by 3 is equal to positive 5. I'm going to multiply both sides by 3. And then I'm going to write my answer up here, and I'm going to get x equals 15. Two steps, right? Easy enough. Pause the video now, and you solve letter B. All right, well, the expression is 4x plus 3. I multiplied x by 4. I added 3. To undo that, I'm going to subtract 3 and divide by 4. I think this time I'll skip rewriting the problem to give myself just a little bit of extra room. So I'm going to subtract 3 from both sides. That'll give me 4x is equal to negative 20. I'll divide both sides by 4. And I'll get x is equal to negative 5. Okay. Now, those two are very, very straightforward. Letter C is a little bit different because I have 12 minus 5x is equal to 87. There's no real big deal on that, but the fact that it's 12 minus 5x as opposed to 5x minus 12 makes it a little bit more confusing for students sometimes. So what I would suggest in a situation like this is use the commutative property of addition. That's right, I said addition, right? Because what I could think of this as is 12 plus negative 5x is equal to 87, right? I can think about it like that. 12 plus negative 5x equals 87, and I can rewrite that equation, if I feel the need, as negative 5x plus 12 is equal to 87. And then it's a little bit more obvious what's going on, right? I'm multiplying x by negative 5 and then I'm adding 12. So to undo that, I'm going to subtract 12 and I'm going to divide by negative 5. Why don't you pause the video and figure out what the value of x is? All right, let's do it. We will subtract 12 from both sides. That's going to give me negative 5x is equal to 75. And now I'm going to divide by negative 5 on both sides. 75 divided by 5 is 15. 75 divided by negative 5 is negative 15. This is a situation that comes up quite a bit in algebra, where we've got a constant, and then it's subtracting, some number multiplying x. I find it easiest to then use the commutative property of addition to rewrite it as a negative number multiplying x plus some positive number, right? It just fits then that two-step sort of form a little bit better than it does originally. All right, let's go to the next row. Here we go. All of these are two-step equations. So what I'd like you to do now is pause the video and try each one of these in turn, and then we'll come back and talk about them. Keep in mind, some of these, or at least one of them, is going to have a fractional answer. Pause the video now. All right, let's do it. Letter D, I've got x plus 7 divided by 3 is equal to 2. So let's undo that. Let's do x plus 7 divided by 3. Let's multiply by 3 on both sides. I'll get x plus 7 is equal to positive 6. Subtract 7 on both sides. 6 minus 7 is negative 1. All right, letter E, if you thought, I'm going to distribute the negative 6 through the parentheses, that's fine. It's just going to take a few more steps than needed. But what I'm going to do, I see x as having 1 subtracted from it, then having negative 6 multiplying it. So what I'm going to do is I'm going to undo the multiplication by negative 6 by dividing by negative 6 on both sides, and then I'll add 1 to both sides. Here we go. Not going to rewrite the problem here. I'll just divide by negative 6, divide by negative 6. 18 divided by negative 6 is negative 3. I'll add 1 to both sides. Negative 3 plus positive 1 is negative 2. All right, you ready for our first fractional answer of the day? Here we go. We have 8x plus 2 is equal to negative 2. I'm going to have to subtract 2 from both sides and then divide by 8. And yes, I'm going to get a fractional answer, and it's going to be negative on top of that. So let's do it. Let's subtract 2 from both sides. Again, be careful. Negative 2 minus 2 is negative 4. Now I'm going to divide by 8 on both sides. And I'll get x equals negative 4/8. Divide both numerator and denominator by 4. And I'll get x is equal to negative 1/2. Be careful, right? When you think about division, it gets easy to think about it always as being the larger number divided by the smaller number. But in this case, when we have that smaller number being divided by the larger number, our answer turns out to be fractional. And I know back in like 4th grade, if I gave you the fraction 4/8 and I said simplify or reduce or whatever terminology you used, you would tell me it was 1/2. You'd tell me it was 1/2 every time, right? The question is now, when you see that 4/8, will you suddenly think, oh, that's 8 divided by 4 and say 2? Hopefully not. Hopefully not. Anyway, let's keep going. Talking about fractions. Ugh. All right, let's take a look at letter G together. We've got 3/4 times x minus 5 is equal to 4. Now, if I'm just doing this by the book, right, I'm looking at this and I'm thinking, well, I multiplied by 3/4, I subtracted 5, and I got 4. So then when I undo it, I'll add 5, divide by 3/4, right, and I'll get my final answer. Well, let's at least start down that path, okay? So the first thing I'm going to do is I'm going to add 5 to both sides of this equation. That is simple enough. and I'll get 3/4 x is equal to 9. Now, don't get me wrong, you could actually very easily divide both, well, very easily might be the wrong way to put it, but you could divide both sides of this equation by 3/4. You've got a calculator. You literally take it out and do 9 divided by 3/4, and you're gonna get the right answer, okay? But most math teachers would say, instead of dividing both sides by 3/4, let's multiply both sides by the reciprocal. Remember, when we divide by a fraction, it is the same as multiplying by what's known as its reciprocal, which is its flipped version, okay? So, instead of dividing both sides by 3/4, I'm going to multiply both sides by 4/3, right? 3 cancels 3, 4 cancels 4. And then remember, I can think about this. I could cross cancel, right? I get that, and then I get 3 times 4, which just gives me 12. A little bit tricky, right? But important to be able to know that little step. Instead of dividing both sides by a fraction, I multiply by the fraction's reciprocal. Okay, now letter H, that's a little bit more challenging because again, we go back to that issue where we've got a constant minus a number multiplying x. I'd like you to pause the video and not only try letter H, but also try letter I, and then we'll go through both of them. All right, well, just like I did in one of the previous problems, I'm going to take this and I'm going to rewrite it slightly. Put a little dividing line here. I'm going to rewrite this as -5/2 x plus 6 is equal to 1. I'm going to subtract 6 from both sides, and I'm going to get -5/2 x is equal to -5. All right. What I'm now going to do is I'm going to multiply both sides by -2/5. Now let's talk about this just for a moment. Okay, you might think, well, I know why he did the 2/5 piece, because he did the 4/3 over here. But why -2/5? Why not just 2/5? Well, the plain fact is, if I just have +2/5 on this side, a +2/5 times a -5/2 will leave me with a -1. -1. And I don't want -1x, I want 1x. I want to know what 1x is equal to. I don't want to know what -1x is equal to, I want to know what 1x is equal to. So if that thing is negative, this thing has to be negative in order to have a negative times a negative be a positive. But at that point, right, the 2's cancel, the 5 cancels, -1 times -1 is positive 1x. Here, the 5's cancel, right, and I have -1 times -2, which is positive 2. All right, simple enough. And I think letter I is actually probably much easier than letter H, so let's launch right into that, right? I've got 6x plus 3 equals -1. I will subtract 3 from both sides. I'll get 6x is -1 minus 3, which is -4. I'll divide by 6 on both sides. Obviously, my answer is going to be negative, and then I can just reduce this fraction. I'm going to divide both numerator and denominator by 2. So I'll get x equals -2/3. That's it. Whew, that was a lot, man. That was 9 problems we just cranked through, okay? But hopefully that lays some basis for just nice 2-step equations, right? Let's keep going. Okay, our main technique, you can't forget this. Our main technique will ultimately be solving equations by using inverses, right? We use the inverses in the reverse order, right? To get that x by itself. So let's go through one of those problems for something that's a little bit more complicated than what we saw before. Let's take a look at exercise number 2. Solve the following equation for x by identifying the operations that have been done to x and reversing them. All right, great. So we did this in the last lesson. What I'd like you to do is take a look at the left-hand expression, write down everything that's been done to x, and then reverse those to solve for x. Pause the video now and take a few minutes to do that. All right, well, we have a lot here, right? Because we are subtracting 3, we're multiplying by 5, we're dividing by 8, and we're adding 2. Okay, so let me write all that down, right? We have subtract 3, multiply by 5, divide by 8, and add 2. So this isn't a 2-step equation. This is going to end up being a 4-step equation. But you already can see the steps. We're going to subtract 2. We're going to multiply by 8. We're going to divide by 5, and then we're going to add 3. Right? We're just going to do the opposite of what we've got here in this order. So let's do it. All right, here we go. Let me rewrite the equation out. 5 times x minus 3 divided by 8 plus 2 is equal to 12. Let's subtract that 2 from both sides. We'll get 5 times x minus 3 divided by 8 is equal to 10, right? Let's multiply by 8 on both sides. We'll get 5 times x minus 3 is equal to 80. Give myself just a little more space here. Ooh, not that much space. Divide by 5 on both sides. All right, 80 divided by 5, that might be one that we have to think about a little bit. That's 16. And then we add 3 to both sides, and we get 19. All right, that's it, right? If we can identify everything that's been done to x, and x only shows up once, that's key, then we just undo what has been done to x. But what if x doesn't just show up once? Let's get into that a bit, right? What if we've got variables on both sides? So there are many times when the variable shows up multiple times on one side of the equation, or shows up on both sides of the equation. In both cases, we will use properties of equality and operations to write equivalent equations, okay? We might use things like the distributive property, the associative property, the commutative property, along with properties of equality. We'll talk about those more in the next lesson, but we'll do all of that to basically get the variable on one side of the equation so we can then use inverses, all right? So let's kind of get into that in exercise number 3. Consider the equation 5 times the quantity x minus 3 plus 2x is equal 4 times the quantity x plus 3. Letter A, by using the distributive property, write equivalent expressions for both sides of the equation, show the work below. All right, so let's do this together. Now, one thing I want to emphasize as I do the following is that while I'm doing this, I am not solving the equation in any way, shape, or form. I'm just going to take what's on the left-hand side. I'm going to treat it as if this isn't an equation at all. I'm going to use the distributive property as well as a few other properties to simplify that. On the right-hand side, I'm just going to use the distributive property to simplify it, as that's going to be easy. But let's do it, right? So here we go. We've got 5 times x minus 3 plus 2x is equal to 4 times x plus 3. Now again, I really want to emphasize here, as I use this distributive property and get 5x minus 15, right, I didn't do anything to solve the equation, right? All I'm doing is rewriting the left-hand side and the right-hand side in ways that seem simpler, right? I could then use the commutative property of addition to rewrite this side as 5x plus 2x minus 15 is equal to 4x plus 12. I can now combine these like terms and say 5x plus 2x is 7x. And then the right-hand side continues to be 4x plus 12. Okay, so now I'm sitting with this equation, right? And it is much simpler looking, at least, than this equation. But all I've done is taken the left-hand side and written an expression that's equivalent to it. 7x minus 15 and all of this stuff are exactly the same, just written in different ways. And more obvious, 4x plus 12 is the same as 4 times x plus 3. Now let's take a look at letter B. Solve the equation for x. Check to make sure the original equation has a true value for the x you find. All right, now we still can't exactly use inverses to solve for x because x is showing up on both the left and the right-hand side. In order to tackle that, what I really want is I want the x's all just on one side. To do that, I could either subtract a 4x from both sides, leaving me with no x's on this side, Or I could subtract a 7x from both sides, leaving me with no x's on the left-hand side. I'm going to subtract 4x from both sides because I'm going to keep the coefficient on x, the number multiplying x, positive. Here we go. Right? So I'm going to write down that equation. It's not my original equation anymore, but it's my simplified one. And the first thing I'm going to do is subtract 4x from both sides. 7x minus 4x is 3x, and I get 3x minus 15 is equal to 12. All of that work I did to finally get my equation in a form where I can use inverses to solve it. Right? Now I suddenly have a two-step equation. I'm multiplying x by 3, I'm subtracting 15, I'm getting 12. So I'll add 15, I'll divide by 3, and I'll get my value of x. Here we go. Plus 15, plus 15. That gives me 3x is equal to 27. Divide by 3, and I'll get x equals 9. Awesome. Now, when you've done this much manipulation, right, think about it. If I were just solving this kind of outright without a part A and part B, I would have done all of this, then I would have done all of this. That's quite a few lines to simply get x equals 9. It really is now a great idea to take this value, substitute it into this original equation, and make sure that equation is true. So let's do that really quick together. All right. I need more room. There we go. So here's my original equation, right? So I'm going to do my check right here. X equals 9. So I'm going to put x equals 9 in for x. It's critical to check it in the original equation because that is the only one that can tell us whether or not we really did all the algebraic steps correctly. So I get 5 times 6 plus 2 times 9 equals 4 times 12. 5 times 6 is 30. 2 times 9 is 18. 4 times 12 is 48. 30 plus 18 is 48. 48 equals 48 is a true statement, which means x equals 9 is a solution. All right, always a good idea to check in the original equation. All right. So now you got to get a little practice. Let's take a look at exercise number 4. Get some more practice with these more complicated equations. Check that your final answer makes the equation true. Generally, use the distributive property when needed to write each side in simplest form. All right, I'd like you to work on letter A, try to work it all through, get an answer, and then let's take a look. All right, now we have to be careful in actually both of these problems because we have some subtraction going on along with distribution. Let's go through it. Here we go. So first thing I'm going to do is I'm going to distribute the 7 through that parentheses. I'm going to get 7x minus 14. Here, I need to be careful and distribute a negative 3 through the parentheses. Negative 3 times x is negative 3x, and negative 3 times positive 3 is negative 9. The right-hand side is not nearly as dangerous because there's only a little bit of subtraction going on. 5 times x is 5x. 5 times negative 3 is negative 15 plus x. Now I'm going to do some combining of like terms. I've got 7x minus 3x, which is 4x. I've got negative 14 and negative 9, which is negative 23. On this side, all I've got is a 5x plus x, so I've just got 6x minus 15. Okay, I've now gotten those left-hand side and right-hand side as simplified as possible. I think, again, to keep the coefficient on x positive, I'm going to subtract a 4x from both sides. Gives me negative 23 is equal to 2x minus 15. I'm going to add 15 to both sides. I'm going to get 2x is equal to, negative 23 plus 15 is negative 8. Divide both sides by 2, and I'll get x is equal to negative 4. Equality is what is known as symmetric. If negative 4 is equal to x, x is equal to negative 4. At any moment in time with equality, if you want, you can always flip-flop it. In other words, if I really want this equation to read 6x minus 15 equals 4x minus 23, I could at this point literally just go, because obviously if 4x minus 23 is equal to 6x minus 15, then 6x minus 15 is equal to 4x minus 23. I think I'm going to skip the check in order to save some time for us on this video. Let's take a look at letter B. All right, now I want you to be very careful as you work on letter B, because again, I've got this distribution of a negative here, and that can severely throw people off. So pause the video now and try to work through letter B. All right, here we go. So that 9 is just hanging out. The big thing I got to be careful with is not to make that 9 minus 6 equal to a 3. Because even though 9 minus 6 is equal to 3, in this case, that 6 has got to multiply through. So I'll get negative 6x, and watch out, negative 6 times positive 1 is negative 6. Then I'll distribute the 2 through. I'll get 2x minus 8 plus 27. Okay, on this side, all I can do is really do 9 minus 6 and get 3 minus 6x. Here I'll do negative 8 positive 27, and I'll get 2x plus 19. Okay. Where do I want my x's to end up? Well, let's keep those coefficients positive. It really doesn't matter. But I'll get 3 is equal to 8x plus 19. Subtract a 19 from both sides. Watch your negatives. 3 minus 19 is negative 16. Right? And then I'll get equals 8x. Divide both sides by 8, and I'll get x equals negative 2. I like the negatives apparently in this problem. X equals negative 2. Again, we'll skip the check. We all know how to do the checks. Take these values, put them back into the original equations, and see if they make those true. All right, let's do a little summary. The main purpose of this lesson was to review the major equation solving techniques that you've learned over the years, right? So nothing today should have been particularly new. It should have tickled some kind of memory bank back there, right? Of course, if you didn't take Math 8, if you're an 8th grader sitting in Algebra 1, then maybe you've had a little bit less equation solving work than other students. But in theory, everything we saw today was material you've seen before. That doesn't mean that it's easy. Doesn't mean you should remember all of it. That's why we reviewed it. And we saw a lot of different things today, including what do you do if x is being multiplied by a fraction? What do you do if there are x's on both sides of the equation? And of course, our favorite technique, which we saw in the last lesson, solving equations using inverse operations. All of this we're going to get a lot more work with in the coming lessons in this unit and throughout the course. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.